Hi, all. I hope you're having a good week and a good day. And I am here to, we're going to do the video on z-scores, sorry. And I'm pretty sure we've already done this before, pretty close. And I know you probably know this, so this should be a quick review. So a z-score tells us how many standard deviations the value is from the mean. And a z-score allows us to compare values that come from distributions with different mean and different standard deviation. And the formula is z-score is equal to the value minus the mean divided by the standard deviation. And this is one example. There's multiple. So this one is 2.3 standard deviations below the mean. This is 1.8 standard deviations above the mean. And this is 4.3 standard deviations below the mean. Remember, it's negative if it's below, it's positive if it's above. So here we have Sally taking two different math achievement tests with different means and standard deviations. So she wants to compare how she did on both. The mean score on test A was a 56 and the standard deviation of 3.5. While the mean score on B was a 65 with a standard deviation of 2.8. Sally scored a 62 on test A and a 69 on test B. Okay, so which test did she do relative to the other? Okay, so we have to do both. So we're going to do test A. And she got a 62 and the mean was a 56. Divide that by 3.5, put that in your calculator, and you get 1.714. And then test B, she got a 69 on it. The average was a 65, and the mean was a 2.8. So she got a negative 1.429. And so since she improved and did better on that, so Sally did better, on test A, even though her grade was lower because the z-score was better. And then here we have Sally had a z-score of 1.31 on test A and a z-score of negative I should have color coded that. Let's do that really quick. Z-score of negative 0.123 on test B. Which test did she do better on compared to herself by many other points? So we don't really know how she did grade-wise on either of them, except for the fact that we know that test A, we don't know what her score was, but we know it had a mean of 56 and a standard deviation of 3.5, and she got a 1.131. And so, and we want a difference. It says, which test did she do better on compared to herself, and by how many points? And so we need to calculate the points, and then we need to figure out which one was technically better. So the first thing we do is multiply by 3.5. So x minus 56 is equal to 1.131. We're just solving for x, y'all. And you should know how to solve for x, but I have a feeling we have since forgotten our math skills on how to solve for x. 3.959, add 56. And if you haven't, yay, this should just be a quick review. So Sally got a 59.959 on test A. Test B, excuse me. Test B, we don't know what Sally made, but we know that the mean was 65. And there was a 2.8, and this time she has a z-score of negative 0.123. So solve the same way. X minus 65 is equal to 2.8, not 5. Let's do 8 times negative 0.123. We do that calculation, and we get that that is negative 0.344. We're going to add 65 to that, and we get that x is 64.656. Now, we're going to subtract that. So 64.656 minus 59.959, and we get that that is 4.697. So Sally did better on test B by 4.697. So we're just looking at raw score on these. And then that's all there is to it. I hope y'all have a great week, a great weekend, and I will talk to you and see you soon. Bye.